This is Demi Birch's 2.4 Adaptations to Long-Term Training assignment. Today we are going to be discussing the different types of training that athletes use and how these adaptations contribute positively to their performance in their sports. Specifically, we are going to look at the different systems in the body and how an athlete within their sport can adapt their necessary systems in order to improve their performance so they have a better chance of performing better and placing better in a competition and their sport. First, we need to understand the different activities and different sports have different demands in terms of their intensity and duration. So the different demands in terms of their intensity and duration, and whether the athlete is working aerobically and anaerobically, and how this sort of impacts our different body systems and how they have to work in order to meet these demands. So therefore, there are different methods to training that athletes use in order to develop the components needed and to make long-term adaptations so they can cope better within their sports. And it's also relevant to not just elite athletes, just performers in general, and for our health as well. Taking part in exercise regularly is obviously going to maintain our health and overall fitness. This is demonstrated through the FIT principle, and this is how frequently we train, how hard we train, how long, and the specificity of our training to our sports. So the first component is frequency, and this is used within a training program in order to gradually increase how often we train, so we can gradually adapt continuously over time, and this can lead to overall improved performance, as the long-term adaptations mean our bodies are more able to cope with the demands, which puts an athlete at more of an advantage in their sport. The next component is intensity, and this is used by gradually increasing the rate at which we work. So this can be anything from increasing the number of repetitions you do, for example, from one set of 5 repetitions lifting a 5 kilogram weight, to then increasing this to 2 sets of 5 repetitions of 5 kilograms, once the athlete can easily and this is only once the athlete can easily perform this without the risk of injury. So the gradual increase in exposure helps to prevent overtraining and reversibility, because if an athlete sustains an injury from overtraining, this is then going to cause reversibility in their performance, and this will psychologically affect them, which they may tell themselves that, and then may be unmotivated in order to progress and reach the same fitness level is going to be a lot more challenging for them. So this helps to prevent that. The next component is time. This is how often we train for and how long our training sessions last and the exercises within them. And as an athlete adapts their training program, their sessions can be prolonged for longer. So this is one way that of time. And so instead of having one session of 20 minutes, this one session can be increased to 25 minutes. And then gradually the athlete can increase the time of the session for longer without feeling the symptoms of fatigue. And later we're going to talk about how an athlete can delay the effects of fatigue. Lastly, we have specificity. And because all performers use the FIT principle in their training, their sports, however, we need to acknowledge may differ in skills and sort of the components needed. For example, a long distance runner whose event is aerobic would need to have efficient cardiovascular and muscular endurance in order to work at this lower intensity, longer duration without fatiguing, whereas a weightlifter would need to be able to generate large amounts of power and have lots of strength, hence why their sport requires a large amount of force from the muscles contracting due to the high intensity, short duration. So they need to produce this force over a short period of time. So their training programs will differ in order to be specific to their sports, so they can develop the relevant components and not train unnecessary ones that could hinder or affect the progress of the vital components. So for example, the long distance runner would not necessarily be wanting to improve their power or strength, because it wouldn't necessarily be beneficial to their sport. If they choose to take part in a program like circuit training, then obviously they can include power or strength exercises to help improve their overall fitness, but it's not going to be as vital as their cardiovascular endurance and muscular endurance. And similarly with the weightlifter, wouldn't really want to improve their cardiovascular endurance because their sport is so high intensity, short duration. It's not really going to be relevant because they don't need to sustain their performance over time. So a training program, let's look at for a marathon runner, would be constructed, or just any performer in general, is first constructed by the performer carrying out a series of fitness tests and then comparing these to the normative data, and then they can determine their areas of strength and the areas that need more development, so they can sort of predict how this is going to help them in their sports and how it's going to be advantageous. However, long-distance athletes need to maintain their cardiovascular endurance, so their training program should consist of continuous training, which is one form that they could use, that lasts about 20 minutes or longer with no breaks or recovery. This could be running around a course or a 400-metre track at a steady pace without stopping. They would train around 3 to 7 times a week at a moderate intensity that is around 40 to 59% of their VO2 peak. For new athletes, they would adapt this to a lower intensity, so instead of running, they would walk around a course for 60 minutes, 2 to 7 times a week at a lower intensity. That's really important. But as the athlete improved and they were an elite athlete, they would then increase the distance or the time running for and even the intensity in order to sustain their performance at this level. Another sort of method that endurance athletes use is altitude training, and this means training at levels where the air is thinner and there is less oxygen to consume. Barometric pressure has actually showed that we only consume around 10% of oxygen that we breathe, so it's hard to consume the oxygen and take it into the bloodstream, so this is why we have to work harder and we get tired more easily. But long-term adaptations will result in the production of more red blood cells, hematocrit, which is our red blood cell count. And more red blood cells means more oxygen can be carried by the hemoglobin, so the athlete will perform better. And the hemoglobin will bind to this oxygen and so associate with it, and will only dissociate when it's absolutely needed, so it stays saturated. And then this then helps the athlete perform better because they're sort of holding their oxygen in times when they really need it. This would help to improve cardiovascular and muscular endurance, specifically for a long-distance runner. However, they could also use cross-training by combining 2 types of training together in order to improve other factors, and this could be something like circuit training that incorporates exercises to improve a series of components so that the athlete can improve their overall fitness. This sort of idea is adopted maybe after an injury to improve their general fitness, so they can keep their fitness going, so they don't cause reversibility in their performance. Whereas a weightlifter who sports anaerobic, for example, would have a training program focused on power and strength, particularly muscular strength. So they could use weight or resistance training, which is a form of interval training that uses weights. So if they wanted to improve their power and strength, they would increase the weight and decrease the number of repetitions. But if they wanted to improve muscular endurance, then they would lower the weight and increase the number of repetitions. An example of their program would be the weightlifter's training program commencing 3 to 5 times a week, and this would then prevent overtraining and reversibility in their performance by giving days for recovery. And at a low intensity, so this could be using 500 to 1,000 gram dumbbells between 8 to 12 repetitions at 70 to 90% of their maximum peak for 3 sets, while targeting the different muscle groups that the athlete feels they need to improve, like the quadriceps and the biceps, or the hamstrings and the triceps. So they are using resistance training. Their session could last up to 30 minutes. So here they are applying the FIT principle to their training in order to make it specific to the individual and their sport, so they can overall improve performance. They could also use free weights and machines and increase the weights gradually by applying the progressive overload principle. And this is really important, that you only increase the weights when the athlete is comfortable in that position where their body is ready for it, because otherwise they can cause injury, and this could really affect their performance and how they participate in their sport. So yeah, it's really important to establish that the FIT principle, although it's one principle, it differs in terms of the different sports because of the different demands that they have, and developing the different components needed in their sports. And this slide is just highlighting what we spoke about, differences between the marathon runners and the weightlifters, and how, because their sports are so different in terms of intensity and duration, they will have much different demands and need different components in order to perform better in their sports, and the different energy systems required. So now we're going to be looking at the anaerobic section and the overall explosive adaptation requirements. So anaerobic performers, as we have previously mentioned with the weightlifter example, seek specific adaptations in order to improve their performance in the components needed in their sport. So by training regularly, the athlete can delay the effects of fatigue and the effects of not being able to function adequately. By long-term adaptations will allow them to develop their body systems so they can cope with the demands in terms of intensity and duration of their sport, as these are the two main components that need to be considered. So as we mentioned, the example of a weightlifter, as they are working anaerobically, their sport requires a large amount of force to be generated in a short duration due to it being explosive. So their training program would consist of exercises and training that would contribute to improving muscular strength and endurance, power and speed. But it is also important to highlight that it's not just performers that need to carry out this. We also need to just normal people need to exercise regularly in order to sustain a healthy lifestyle. So this means we are strong enough to function and carry out everyday tasks. This becomes increasingly important as we age due to our bodies and vital organs becoming weaker, or if we start to lead a more sedentary lifestyle. It's anything from swapping walking to work by using the car, sitting at home watching TV when we could be out exercising or going to a fitness class. And this is so we're reducing considerably the amount of exercise and we become less active, which is what sedentary lifestyle is. And this then results in a loss of power and strength due to our bodies experiencing atrophy, which is the opposite of hypertrophy. So our muscles and bones and organs actually reduce in size, and this makes us more at risk of developing conditions like osteoporosis and osteoarthritis, which we will come to later in the video, and suffering from disease in our vital organs and conditions which impair these. So people and performers try to delay this and reduce this by regular exercise so we can remain independent and reduce the risk of injuries. This is also so that we can take part in activities by ourselves and be independent, and we don't have to rely on other people. And we maintain our bodies so we can sort of delay the effects of fatigue and delay these sort of conditions and health defects and prevent them at any cost if we can. And we should also recognise that muscle mass helps to increase muscle metabolism, and that we can adapt positively and negatively our health depending on how much exercise we do. So yes, it shows us that there's also negative effects of exercise as well. By training too hard and too regularly can actually also cause injury, and then this then prevents the person actually from being active, so then they actually reverse in their performance and their fitness actually decreases. And then this can be hard to regain fitness, especially if you're, as we said, an elite athlete. Something that we don't really want to be dealing with. We want to sort of exercise regularly at a moderate intensity so we can sustain performance, and so that we can sort of prevent ourselves from getting these diseases from our vital organs and systems not being able to work efficiently.